Hi, welcome back to IV Tutor. My name is Edmund, and we want to look at the second of three types of questions that you get on the Big O. And in these questions, we are going to be looking at a few calculations that you have to perform with the Big O. And these questions are very simple because the structure is always the same, the method is always the same. You just have to know how to apply the method. So they give you two algorithms, right? And so the approach or the structure of these questions is you're given two algorithms. And for those two algorithms, you are given the time for the first algorithm, and you are also given the size of the first algorithm. Then you're also given the time of the second algorithm and the size of the second algorithm. But they won't give you everything. Either they give you these two and this, and you have to find that, or they give you these two and this, and you have to find that. So it's a very simple equation that you eventually have to create. Let's look, for example, at this question that says, an algorithm takes 5 seconds, 0.5 seconds to execute an input size of 100. So already for the first algorithm, you're given the time and the size. How long is it going to take for an input size of 500 if the running time is linear? So now you're given the input size of the second algorithm, and you have to find the time, which is one of the missing 4 aspects to these questions. So the way you approach these questions is you first have to understand what your Big O is. In this case, they say it's linear, which means it's just n. That's your Big O. It's very crucial, because what you then have to do is you take the time of your first algorithm versus the size of your first algorithm, then you say equals the time of the second algorithm versus the size of the second algorithm. And on size, you are applying the Big O to your size. That is the most crucial thing to do, okay? So if we do this with these inputs, we are saying 0.5 seconds over. Now our input size is 100, but you apply this to your Big O. So you replace n with the actual size, okay? Which means this becomes 100, because in this case, our Big O is just n. And we say equals the time for the second algorithm versus the size for the second algorithm. And again, you are replacing your Big O with the actual size. Now you end up with an equation. And once it looks like this, then you can just do simple cross multiplication. So now you can go T2, multiplied by 100 is equal to 0.5 multiplied by 500. And then you divide by 100 both sides in order to get your time. And this gives you 2.5 seconds. You are allowed to use a calculator if you struggle to do this off your head. But in most cases, the questions are mostly doable, especially in exams. They give you questions that you can actually do without the need to use a calculator. But I know people are always like, no, just to be sure, you have to use a calculator. Go ahead if you want to feel comfortable. All right, so let's look at another question. Here, the Big O of our question is log n, which means when we do our equation, we are going to replace n with the actual size. And let's go 10 seconds for an input size of 100, which means it's going to be 10 over log 100. What have I done? I replaced n with the actual size. Is equal to, for the second algorithm now, how long, which means we need the time for an input size of 10,000. Right? You need to calculate T2. So at this point, it's not just a mathematical equation. You can proceed whichever way you feel comfortable. You can start by making T2 the subject of the formula, or you can start by simplifying your values and then proceeding that way. It doesn't matter. So if we do the same thing here, you cross multiply, your items, which means you end up here with 10 T2 is equal to log 100 multiplied by log 10,000. You divide by 10 both sides, and your T2 is going to be log 100 is equal to 2. right? So this is equal to 2, this is equal to 1, 2, 3, 4. From the slides that we did, 10 to the power 4 is equal to 10,000, which implies that log base 10 of 10,000 is equal to 4. That thing that we did before in the previous video, okay? So this means that you are dealing with T2 is equal to, what am I missing here? 8 over 10, which is basically equal to 0.8 seconds. Is that right? What am I missing here? 10 over log 100 is 10 over 2. Input size of 4. Yeah, that's it. Oh, sorry, geez, my mistake. I didn't do my cross multiplication well here. Just get this off the way. So this should be log 100. T2 is equal to 10 log 10,000 over log 100 here over log 100 here. Then divide by, then T2 is equal to 10. This is now going to be 4. This is 2, which is equal to 40 over 2, which gives you 20 seconds. Yeah, therefore your answer is 3. Sorry about that. Right, next question. An algorithm takes a second for an input size of 10. How long? Again, we are still looking for time, and our big O is 2 to the power n. Again, replace n with the actual size, which means you are saying 1 over 2 to the power 10, because that's your thing, equals your time. You can also use x. I mean, it doesn't whatever you find comfortable, which is your time is equal to x over 2 to the power 50, because that is your input size. And then you do your cross multiplication, you end up with 2 to the power 10x is equal to 2 to the power 50, over 2 to the power 10 over 2 to the power 10, and then your x becomes 2 to the power 50 minus 10, which is equal to 2 to the power 40 there, which is 1 there. Okay, so once you get your equation right, pretty much I would say you are done, because the rest is just going to be simple maths: cross multiply, divide, and you've got the answer. Here's another one. An algorithm takes a second for an input size of 10. Our running time is quadratic. They don't always give you n squared. Sometimes they simply say it's quadratic and then they stop there. You have to remember a quadratic equation, highest power n squared is squared, right? So if they say it's quadratic, then n squared. If they say it's cubic, then to the power 3, right? So don't forget that. So your big O here is n squared, which means you're going 1 over 10 squared, right? Is equal to, what are we looking for? What is the largest size? Now we're looking for the size. What is the time? 25 seconds, which means it's 25 over n squared. We are looking for n. You do not change the big O. It's what it is, right? Now we need to find n. So if we cross multiply here, we are going to end up with n squared is equal to 25 multiplied by 10 squared, which means your n is going to be the square root of 25 multiplied by 10, which should be 5 multiplied by 10 squared, which is 5 multiplied by 10, which gives you 50. Therefore, that becomes your answer. But remember, from this point forward, you can actually use your calculator if you want to make it easier, which means this would give you 25 multiplied by 100, which gives you 2,500. And then you can then just compute the square root of 2,500, which gives you 50. So which approach you take, it's a matter of personal preference. Right, another question here. What are we looking for? The size. What is the big O? Cubic. It looks like I prophesied. Okay, now it's 10 over 1,000 cubed. Okay, because it's cubic. It's n cubed. Replace n with the actual size. That's what you end up with. Write this nicely here. It's just to avoid some confusion. So we are going to have 1,000 cubed, which is equal to, what is the largest size that can be solved, or what will the, that's some broken grammar there. What will be the largest size of input what would the largest size of input be? Okay, that can be executed in 80 seconds. We are looking for the size, that's what matters. Here over n cubed. Okay, so you do the same thing, you end up, 10 n cubed is equal to 80 multiplied by 1,000 cubed, which means your n cubed is going to be 80 multiplied by 1,000 cubed over 10. You can do your maths there. This gives you, 8 over 10, okay, let's just do it this way. If I continue, this cancels that, which is equivalent to 2 cubed multiplied by 1,000 cubed. Therefore, my n is equal to the cube root of 2 cubed multiplied by 1,000 cubed. So if you apply the cube root there, you end up with 2 multiplied by 1,000, and you end up with 2,000. Therefore, your answer there becomes 3. Okay, but again, remember, feel free to use your calculator if you are scared of making mistakes doing these calculations. Otherwise, that's the second type of questions you get under the big O. It's always very easy. You end up with, all you do is you equate your time over size of your first algorithm to your time over size of your second algorithm. Then you find your time or you find your size. The most important thing to remember is do not forget to apply the actual big O when putting your size on your equation. Otherwise, that's it. Let's move on and look at the last and final type of questions that you see under the big O, and let's do that in our next video. I'll see you there. Yes.